So the first premise of Pascal's argument is this. It's always rational for you to maximize expected value. What does this mean though? What is this expected value and what is it to maximize expected value? Well, to explain the idea of expected value, it's helpful to articulate and explain a slightly simpler notion, and then we'll work towards the more complex one. Let's talk about expected dollar value. This is a number that we can associate with bets that have dollar rewards. So, for example, let's suppose that I offer you a bet. If you accept it, what's going to happen is I'm going to toss this coin. And if the coin lands heads, then you'll get $3. You win $3. If the coin lands tails, then you'll lose $1. What is the expected dollar value for you of that bet? Well, that's the average amount you'd expect to win per play if we were to play this game or run this bet many, many, many times over. So in this case, we could think about it like this. If we were to run this bet 1,000 times over, you'd expect to win roughly 500 times, and each time to win $3. And you'd expect to lose roughly 500 times, and each time to lose $1. So you'd have expected over the course of those 1,000 bets to have accumulated $1,500 in wins and $500 in losses. The net of that would be $1,000 of wins in your 1,000 plays of the game. And so your average win, your mean win per play, would be $1. So the expected dollar value of that bet is $1. We can put it a little bit more technically and say the expected value per bet is we can work out by looking at all the different things that might happen if you were to take the bet. All the different rewards that might come to you, where a reward is either something that a gain that you make or a cost that you bear, and saying for each of them, multiply the probability that you associate with your getting that reward, like the chance that, as far as you're concerned, that you'll get a reward of that value, by the reward itself, and then sum up for all the possible rewards, and we get a number, and that's the expected dollar value associated with the bet. So that is expected dollar value. The notion of expected value simpliciter just generalizes that. So the idea is this. For an option that you can take, we look at the outcomes of your taking that option. The outcomes of your taking that option are the possible things that might happen so far as you're concerned if you take the option. You don't know exactly what will happen if you take the option, but there are a range of things that might happen if you take the option. Call each of these, the things that might happen if you take the option, the outcomes of the option. When you are thinking about whether to take the bet, in which I spin the coin and you get $3 if it turns out heads, you lose the dollar if it turns out tails, the outcomes associated with your taking the bet would be 1, you're getting $3, 2, you're losing $1. Those are the two different outcomes of your taking the bet. And with each of those outcomes, we can associate a number where the number represents how much you want the outcome to come about. So it might be that the number you associate in this case with your winning $3 is 3, and the number you associate with your losing $1 is -1. But it's not obvious that has to be so. That depends on whether you like money. If you really don't like money, then you're not going to associate higher value with your winning $3 than with your losing $1. If you just don't care, then it's not going to make any difference to you. even if you do like money, but you already have so much of it that further money is of no interest to you. If you're an internet squillionaire, you don't want any more to win $1, $3 than you want to lose $1. So we can represent these things by associating values with the outcomes of the options available to you. And then we define expected value, something associated with an option, in this way. So let O1, O2, O3 and so forth be outcomes that might, so far as you know, come about if you take a particular option. Call it option A. And let the value associated with O1, the value associated with O2, and the value associated with O3 and so forth be the numbers that represent how good these outcomes are for you, how much you want these outcomes to come about. Finally, let probability associated with outcome 1 given A, probability associated with outcome 2 given A, probability associated with outcome 3 given A, and so forth, be numbers that represent how likely you think it that each of the outcomes will come about if you take option A. So the probability associated with outcome 1 given A represents how likely you think it that outcome 1 will come about if you take option A. Now, with that stage setting done, we define expected value in this way. The expected value for you of option A is the probability you associate with outcome 1 coming about given that you take option A, multiplied by the value for you of outcome 1, plus the probability you associate with outcome 2 coming about given that you take option A, multiplied by the value for you of outcome 2, plus the probability you associate with outcome 3 coming about given that you take option A, multiplied by the value for you of outcome 3 coming about, and so on and so on and so forth. Sum all those things up and we get a number. And that number is the expected value for you of the option A. We can put this equation in short using the sum sign. We can say that the expected value for you of option A is the sum for all outcomes O of the probability of O coming about given that you take option A multiplied by the value you associate with O. So the options open to you in a particular situation in which you're deciding what to do may have different expected values. And the distinctive idea that's motivating expected value theory is that if you're rational, you will always take the option with highest expected value. Why? Well, doing that in the long run will benefit you. That's perhaps the best that can be said. The rational person looks at the options available to them, tries to assess which of them has highest expected value, and then takes that one. So that's premise 1 of Pascal's argument reconstructed in this modern way. The second premise of Pascal's argument, reconstructed the way that we're reconstructing it here, was this. For you, believing in God maximizes expected value. Why would you think this? Well, look, you're in a situation where you face a decision. Shall I believe in God or not? What are the outcomes associated with your taking the decision to believe in God? Well, look, there are two things that might happen. One is that you live the devout life of a believer in God and then are rewarded with an eternal life in heaven. You were right, there was a God, and he gave you life in heaven for your devotion and belief. How likely do you think it is that that will happen if you believe in God? Well, that will happen if there is a God who rewards believers with life in heaven. Associate a probability with that. Doesn't really matter what it is. And I'll represent that with the symbol P God. That's a number. Represents how likely you think it is that there's a God who rewards believers with life in heaven. What's the value now associated with that outcome? Well, Pascal says that's infinite, that eternal life in heaven you associate with that infinite value. It's unbounded. As you get more and more and more days in heaven, that's better and better and better for you. And there's no point at which they start losing their value. They don't get less good as time goes by. So the value associated with eternity in heaven for you has got to be infinite. Now, consider another thing that might happen if you believe in God. You live the devout life of a believer and then aren't rewarded with anything. Turns out you were wrong. There was no God who rewards devotion with eternity in heaven. Your life is over. What's the probability of that coming about? Well, that's the probability that you associate with there being no God who rewards devotion with life in heaven, with eternity in heaven rather. And the value for you of that outcome, well again, we can just represent that with a symbol. It's the value for you of just living a devout life and then getting no heavenly rewards. Call that V devout. Now, the expected value for you then of believing in God is just this. P God, the probability you associate with there being a rewarding God, multiplied by infinity, plus P no God, the probability you associate with there being no rewarding God, times V devout, the value you associate with a devout life. Now, just so long as P God is not 0, just so long as it's a little bit more than 0, just so long as you have any credence at all that there's a God, a rewarding God, then that sum is going to turn out to be infinity. The expected value for you of believing in God is going to be infinite. Of course, if you're completely certain that there's no God, then it's not going to be infinite. But if you have any inkling of doubt at all concerning the non-existence of God, then it's going to be infinite. Now look at the things that might happen if you don't believe in God. Well look, if you don't believe in God, then you're not going to be rewarded with an eternity of life in heaven. So the outcome, if you're not believing in God, is just that you live the dissolute life of a non-believer, and that's it. No heaven. The probability you associate with that outcome is 1, and the value for you is just whatever value you associate with leading a dissolute life and then not being rewarded with eternity in heaven. Call that V dissolute. It doesn't really matter what it is. Pascal's point, understood this way, is that just so long as it's finite, the expected value of your not believing in heaven and God, not believing in God, is finite. And infinite expected value is greater than finite expected value. So, believing in God maximizes expected value. Believing in God has higher expected value than not believing in God. And so, by the first premise of his argument, that's the rational thing to do. The rational thing to do is to believe in God.